data processing. In the decades after Charles Babbage and Ada Lovelace introduced their revolutionary ideas, the world began to change at an incredible pace. Factories expanded, cities grew, and machines slowly replaced traditional manual labor. Precision engineering improved year after year, allowing inventors to build mechanisms that were far more reliable than anything that had existed before. This new industrial environment created the perfect foundation for the next step in computing. Engineers started constructing the first real calculating machines, devices made of metal, gears, levers, and rotating shafts. These machines could follow mechanical instructions and perform tasks that once required hours of human effort. At the same time, a powerful concept emerged: information could be stored on punched cards. Originally used in automated looms, these cards proved that machines could be guided by patterns instead of human hands. It was a quiet but groundbreaking moment, the true beginning of data processing. As mechanical engineering continued to advance, inventors around the world began experimenting with new ways to automate calculations. One of the most important developments was the creation of machines that could perform complex operations using only gears, levers, and rotating shafts. These early devices were often large, heavy, and difficult to build, but they represented a major step forward. Engineers studied how to translate mathematical rules into mechanical movements. Each gear represented a number, each lever controlled a function, and every rotation carried information from one part of the machine to another. For the first time, calculations could be repeated with precision, without human error. These machines were not fast, and they were not easy to operate, but they proved something essential: a machine could follow instructions. This simple idea would become the foundation for all future computers. As these mechanical machines became more advanced, engineers realized that they needed a reliable way to store and repeat instructions. This led to the idea of using physical patterns to control a machine's behavior. One of the earliest and most influential examples was the punch card. By creating holes in specific positions, inventors discovered that a machine could read these patterns and perform actions automatically. This breakthrough changed everything. Instead of relying on a human operator to turn gears or pull levers at the right moment, the machine could now follow a sequence of instructions on its own. It was the first step toward programmable systems. Although these early punched card machines were slow and limited, they introduced a powerful concept: information could be encoded, stored, and reused. This idea would shape the entire future of computing. As technology moved into the early 20th century, machines became larger, faster, and far more complex. Mechanical parts were now combined with electrical components, creating powerful electromechanical systems. These new machines used relays, switches, and long rows of cables to process information at a speed that had never been possible before. For the first time, data could be handled automatically on a much larger scale. Punch card systems became the standard tool for governments, companies, and scientific institutions. By feeding stacks of cards into these massive machines, entire calculations and datasets could be processed without human intervention. Although these systems were noisy, energy-hungry, and extremely large, they marked a turning point. Computing was no longer just mechanical; it had entered the age of electricity. As electromechanical systems continued to grow, a new generation of machines emerged that pushed the limits of what was possible. These early computers filled entire rooms and required constant supervision. Rows of relays, switches, and vacuum tubes worked together to process information faster than any mechanical device ever could. For the first time, machines could perform thousands of operations in a single session, making them powerful tools for science, engineering, and government work. However, they were extremely fragile. A single failed tube or relay could stop the entire system, and repairs often took hours. Despite these challenges, these early room-sized computers proved that automated electronic calculation was not only possible, but essential. They marked the beginning of true computing as we know it today. As technology continued to evolve, a major breakthrough transformed the world of computing: the invention of the transistor. Unlike vacuum tubes, transistors were smaller, faster, and far more reliable. They produced less heat, consumed less energy, and allowed engineers to design machines that were more compact than ever before. This shift marked the beginning of a new era. Computers no longer needed entire rooms filled with glowing tubes and heavy equipment. Instead, they could be built with thousands of tiny components placed on circuit boards. These new machines processed information at incredible speeds and opened the door to more advanced scientific and commercial applications. The transition from vacuum tubes to transistors was one of the most important steps in computing history. It laid the foundation for modern electronics and set the stage for the digital revolution. With the rise of transistors, engineers soon discovered that even greater progress was possible. By placing multiple transistors and electronic components onto a single piece of material, they created the integrated circuit. This invention allowed computers to become smaller, faster, and far more efficient than anything that had come before. Integrated circuits made it possible to combine thousands of components into a space no larger than a fingernail. Machines that once filled entire rooms could now fit on a desk, and their performance increased dramatically. This shift opened the door to new industries, new technologies, and new ways of thinking about information. For the first time, computing was no longer limited to governments and large institutions. The foundations for personal computers were being laid, and the digital world was beginning to take shape. Today, we have traveled through more than a century of innovation, from mechanical gears to electronic circuits, from room-sized machines to the foundations of the digital world. Every step, every invention, and every breakthrough has shaped the technology we use today. And next time, the story becomes even more fascinating, because the rise of artificial intelligence begins to transform not only computers, but the entire world around them. If you enjoyed this journey through the history of computing, consider subscribing to the channel. Your support helps us continue creating documentaries like this one. Thank you for watching, and see you in the next episode.